Well, today we're going to start three-dimensional equilibrium here in Chapter 5, 3D equilibrium. So in 2 dimensions, we had 3 equations to satisfy. Some of the forces in the x is equal to 0, some of the forces in the y is equal to 0, and then some of the moments about any point. In 3D, we have 6 equations to satisfy. Some of the forces in the x, y, and z all have to be equal to 0. And then some of the moments in about all 3 axes, or in all 3 dimensions, have to be equal to 0 as well. We can analyze this the vector way, which we're going to talk about in a little while. But we're going to start with the scalar approach. And then with the scalar approach, we will do one axis at a time. We'll find moments about that axis using all the forces that are obvious or necessary in that axis. Set it equal to 0. Set the equations equal to 0, and then solve. We'll usually get a series of equations, 2 or 3 equations, something that we'll have to put together. We're going to start here with this picture here, this little problem where we have a plate that weighs 1,000 newtons. It's a triangle plate, and we're going to try to find out the reactions. We're going to find out what happens at A and B and D. So look carefully at what's going on. The plate has some weight. There's a couple of forces applied. There's a string holding it up right here, and then there's 2 pins or 2 supports right there. Let's go ahead and draw the weight in first of all. The weight acts through the center of gravity. Because this is a triangle plate, then the center of gravity is kind of out in here someplace. So let's go ahead and draw the center of gravity, and I'll draw a weight here, just kind of acting straight down through the center of gravity. Now this drawing is a little bit busy. It's got a bunch of dimensions and a bunch of forces. What it might be helpful is to view this as a 2-dimensional object from one of the axes. So let's try looking down that axis like we did before, using when we were in the moment section or moment chapter. We're going to look at this from that axis. So I'm going to draw this picture looking down that axis. So here's my side view, if you will, and what I have is this is the x-axis, this will be the z-axis, and this is the y-axis looking down there. Let's look at the supports first. I know I have a support here at A, and then there's also going to be something going up at B, so I'll say those are A and B. Then the last support over here is coming at the end, which is D. Acting down, we have those 3 other supports, or those 3 other weights. So I'll have the 900, we'll have the weight of 1,000, and we'll also have the 600 applied force. The lever arms may be obvious, but let's go ahead and draw them in here. The 900 has a lever arm of 0.1, viewed from this side. The 1,000 is 1/3 of the whole length. So the whole length here is 0.8, and the 1,000 acts at the 1/3 spot. So let's go ahead and put that lever arm here of 0.8 over 3. Then the 600 has the lever arm that's obvious here, which is 0.5. Okay, the way we do this is the way we did before. Some of the moments about the axis to try to find out the unknown. So it looks like D would be the unknown in this view. So let's see. Sum of the moments about the x-axis is equal to 0. So here I have minus 900 times 0.1 minus 1,000 times 0.8 over 3 minus 600 times 0.5 plus D times 0.8 is equal to 0, and I can solve that for D is equal to, let me zoom out a little bit, D is equal to 820.8 newtons. Okay, solved our first unknown there. Let's look at this down the y-axis, looking at this way. So I'm going to draw another view here. I'm going to say that down the y-axis, here's the y-axis, this will be z, and this is x going here. I still have those 2 supports. I'm going to have that the B and the D visible here, and then A is visible over here. So we'll have A, and Then from this view, we should be able to see that 600 and the 1000 and the 900 looking backward like this. All right, let's look at the lever arms carefully. 600 has a lever arm of 0.2, pretty obvious from the drawing. How about the 1000? 1000 again would be whatever this dimension is, it'll be 1/3 of that. So this looks like a full meter, and so the 1/3 dimension should be 1/3. Then 900 has the lever arm of 0.6. Okay, let's sum the moments about the y-axis then and see what we can discover. Sum of the moments about y is equal to 0. So I have 600 times 0.2 plus 1000 times 1/3 plus 900 times 0.6 minus d. I'm going to go ahead and put that, sorry, minus a. Minus a times 1 is equal to 0, and then I can solve that for a is equal to 993 newtons. All right, so I've got 2 of my unknowns solved for. How do I get that third one? Well, there's more than one way of solving this, but if we sum the forces in the z, it looks like that last unknown should show up. So let's do sum. The forces in the z is equal to 0. So going up, I have a plus b plus d. And then going down, I got 900 minus 1000 minus 600. And all of those have to be equal to 0. And that gives me my final unknown of b is equal to 685.9. 685.9 newtons. All right, so with that we've solved for all 3 of the unknowns, and that's a pretty straightforward way of looking at these problems. All right, let's look at one more. Here I have the weight of a rectangular plate is equal to 500, and we still want to find these tensions. We want to find A, B, and C. So you can look carefully at this. These are all 3 going up. There's a weight. In this case, its uniform is going to be right there in the middle. So let's go ahead and draw the weight. It's going to be going down, and the weight says it's going to be 500. And because it's in the middle, we can know that it's going to be halfway between the 3, and then halfway between this dimension being 4. All right, some of the forces or some of the moments then about each axis. We can look at this with the x-axis, we can look at this on the y-axis, and some of the forces in the z. We have quite a few unknowns in each equation. In other words, each equation is unable to solve for a specific unknown when we do it this way. It is a 3-equation, 3 unknowns problem, and it's not that hard to do with a substitution method. But what I want to point out here is a little more of a powerful method using some of the moments about different axes. So the axes are given, x and y and z. However, I could also sum the moments about this axis. If you see that, all 3 of these forces go through that axis. The 500 causes a rotation in one direction, and then this one will cause a rotation in the other direction. So in other words, if I call this the AC axis, where this is A and this is C, I can sum the moments about the AC axis and solve for B with one equation. In the same way, I can solve the moments about, or I can sum the moments about the BC axis, where I'll just label this BC. If I sum the moments about the BC axis, because those 2 forces are given, I can solve for that A with one equation. Then I can sum the forces in the Z and find out the other unknown. So look for opportunities where you can sum the moments about other axes. It's a very convenient, very powerful way of solving some of these problems.